Mic test, mic test. Okay. Think everything is working. Welcome back, everybody. I know that it's been a couple of days since I last streamed. Um, been pretty busy, and um, to be completely honest, just need a little bit of a break. Teaching or streaming every day can have take a toll on you. Um, but we're back, and I missed it, and I hope everybody's had a good week so far. I know that, you know, like I said, missed a couple of days. Hopefully, um, the continuity hasn't been broken up too much. But um, just to review, last time what we talked about in chapter 4 of Cisco Networking Essentials, we talked about the different kind of cables. And yeah, it wasn't too heavy, intensive, or anything like that. So I'm sure that um, if you need just to jog your memory, just go back and briefly view it. Like I said, it wasn't too entirely intensive, right? But today we're on chapter 5, and we're going to be talking about communication principles. And this is the really important stuff, right? Because last stream I said that this chapter is very important, um, especially when it comes to the TCP/IP and OSI model. Um, and we're going to learn something called protocols. We're going to learn communication standards. How is it that with all these devices nowadays, how are we on the internet? How is everything being governed, right? There are organizations out there that we will learn. We're going to learn again the OSI and TCP/IP model, and we're going to learn the Ethernet, the layer 1 and layer 2. So let's get right into it. So um, the rules, right? When you think of rules, think of protocols. Um, and there are going to be three elements: uh, the source, the medium, and the receiver, the destination, right? Source, medium, destination. Um, and then in this example, there's what is this example? Let's play the example. Okay, that was okay. Um, okay. But yeah, so all communication methods have three elements in common. Like I said, there's a message source or sender, uh, and they're saying that the source are people or electronic devices that need to communicate a message to another individual or device. The second element of the communication is the destination or receiver. That's going to be the person that obviously receives the message. And then the third element, like we said, transmission medium or the channel. This is how the message is sent. This is what is the how do we get the message there, right? Um, so yes, communication protocols. Okay, so um, in this example, there's so there are some things that we need to agree upon, right? Before we can start communicating with each other, there are things that we need to agree upon, um, so that we can establish communication. The first one is being the method, and in this example, this person asks, "Can we use sign language?" And then this person who writes on the paper says, "I don't know sign language. Can we use writing?" And then this guy says, "Okay." So the first uh, agreement on the method is established. And then there's a language. Um, I can speak Japanese and English. I can speak Spanish and English. And then they both agree. Okay, then we can use English. and then the confirmation. Um, Not too entirely yeah, like pretty straightforward. And then like I said, when you think of rules, think of protocols. These rules or protocols must be followed in order for the message to be successfully delivered and understood. Um, and so why do protocols matter? Um, Networking protocols define many aspects of communication over the local network. And then in this table, we're going to see the characteristics of the protocols. The first one being message format. When a message is sent, it must use a specific format or structure. Message format depends on the type of message and the channel that it uses to deliver the message. Message size. We'll learn later on that like with packets and frames and data, there can only it needs to be sent in a certain size. And so, for example, with layer one and layer two at the Ethernet uh, layer, which we will learn later in this chapter, we call those frames, right? And frames, I believe, can only hold up to I think 1500 bytes or a little less than that. And then and it can be as little as I believe. Don't quote me on it. I want to say as little as 64 bytes, um, but don't quote me on that. But the point being is that the message size there are rules within the protocols, right? So with message sizes, you don't want it to be too big or you don't want it to be too small. There are you want it there are parameters set. Timing. We saw in our last stream when we used ping, right, and we received replies back. Um, there are we mentioned that you could time out, right, and we'll learn in layer three, and well that was layer three. We'll learn in layer four um, when we talk about TCP and UDP, and we talk about more specifically about TCP. We'll talk about how TCP establishes a handshake, and there are something called SYN flags and acknowledge flags, um, but that's a little bit later. Encoding, how these bits are encoded, are a lack of word encoded, like are they using sound, light, waves, electric pulses? Encapsulation, this is a word that you should get really familiar with. Basically, um, just to give you an example, what do you call those Russian dolls? So yeah, like when we get into the TCP/IP model, uh, it's basically like this, right? So you start with when you're sending data, you start from the top down, and so in this example, like this would be the data, and then this would encapsulating means um, you you take that data and then you put it in, and then again, and then you put it in again, just like the Russian doll, right? Like you're putting it in here and then in here. I mean, I guess it was a bad example saying from top to bottom because, or actually, yeah, I guess that's not the right way. But encapsulating meaning like you take this and then putting it in here, and then repeating the process of putting it in another frame into another frame. Um, but we'll talk about that a little later. But you do want to get very familiar with the term encapsulation. Encapsulation is the process of adding this information to the pieces of data that make up the message. In addition to addressing, there may be other information in the header that ensures that the message is delivered to the correct application on the destination host. And then the last one, message pattern. Um, some messages require an acknowledgement before the next message can be sent. So that's That's what I meant by TCP handshake, with the send and acknowledge flags. Um, when you send a TCP packet, the receiving end has to acknowledge it, and it will send an acknowledge flag, and then and then that's how it knows, okay, I can send the next packet. So let us continue. So we talked about how, well, there's so many devices on the internet. How are these things being regulated? Um, and there are organizations that set standards and rules for that. Where, you know, if you sent me an email on your laptop, I can access it through my smartphone on the internet because all devices have to follow the same rules. All devices using the internet, we all understand it. It all understands and agrees that this is the way that things need to be done. And these are some organizations. IEEE is a big one that you probably will see a lot. You'll see Internet Engineering Task Force, IETF. And then there's something called a request for comments. And this is pretty much when new things are, when you want to implement changes or propose new rules or standards. Um, that's basically what a request for comment is. Um, Not too, like, it's good to know, but don't stress over it. That's what I'll say. Um, but it is good to know these things. So let's check our understanding. The rules that govern network communications, including the message format, size, timing, and encapsulation, are known as network protocols. Remember the rules. When we think of rules, think of protocols. The IETF records and publishes internet standards and documents known as RFCs. We didn't talk about IPSs. We didn't. I don't think we talked about any of these three. So let's check. Okay, good to go. So I don't generally like showing videos. What was this one? The network protocol?
Computer networks use
Okay, so I guess we can watch this video. This guy, I call him the network Bill Nye the Science Guy. Um, but let's watch this video. This one, we can talk about it here, right? Um, so let's go ahead and watch this video.
protocols. Protocols are the rules that govern communications. Very similar to the protocols used in human communications. In human communications, we have protocols like language. If I'm speaking to somebody, we want to use a common language so we can understand each other. We may have other types of protocols that we use. Do we talk formally or informally? How we greet each other. There's a protocol for that. Even how we dress or conduct ourselves. All of this are protocols that help govern human communications. In computer networks, we use protocols also to help govern communications between two devices. For example, here are some common protocols. A computer message is actually made up of several protocols. In this message here, we have the Ethernet protocol. The Ethernet protocol governs network interface card to network interface card in the same network. We have Internet protocol. Internet protocol governs communication from the original source all the way to the final destination. Make sure the message gets there and gets there all along the way. These devices called routers know where the packet is going. IP is for that. There's TCP, Transmission Control Protocol. This protocol makes sure that the information gets there reliably. And if it arrives out of order, if there's a sequence of packets all associated with the same message, it makes sure that they get reordered properly. And then there's HTTP, Hypertext Transfer Protocol. This protocol governs the exchange or transfer of HTML, hypertext markup language. So when we are requesting a web page or downloading a web page, the message can contain all of these protocols. So in computer networks, we use many different protocols. Learning about network protocols will give us a better understanding of how networks operate, how to implement and configure networks, and also how to troubleshoot networks.
Okay. I mean, clearly we saw that guy reading off a script, but so basically the most important part, right?
Make sure the
Let me see if I can get. Okay. So basically, network protocols, like he mentioned in the video, they're just rules, right? Just standards and rules. So with the in terms of network rules, network protocols, like um, they're broken down into something called a protocol stack. And this is how our computers can communicate with each other. And it's how we can get on the internet and things like that. It's through this protocol stack. And so in his example here, right, this is what we would call the TCP/IP model, right? There's the Ethernet layer that we talked about way in the beginning um, of networking essentials. We talked about NICs, right? NICs, network interface cards. Um, that's going to be included in the Ethernets, but also we talked about in our last chapter, in chapter 4, we talked about cables, right? And we all specifically talked about Ethernet cables, right? Um, so NICs and like NICs and cables are going to be generally found in the Ethernet layer, um, network layer. That's network access layer, more specifically. Um, and then we got IPs. We talked about um, I don't know if we actually got to talk about IPs, but we talked about logical topologies. We talked about how IPs uh, have subnet masks. We didn't get to really talk about subnet masks, but we mentioned how subnet masks identify the network that hosts are in. So this is how we can find uh, each other, right? Like that's how I can send, um, like if we're in a network, that's how I can send you a message or data if I know your IP address. And more specifically, if I'm going out of the network, I need to know your public IP address, right? Um, TCP, we talked about it. Again, he said it. It's a reliable delivery, and we will get into later. When you send data, specifically with TCP, the packets are all numbered because not all data is going to go through one router. Data can go through several routers because I mean that's just how it works, right? Sometimes they're not all going to go to one router. Data can go through many routers, many routes, and then they all reach the destination, right? And he mentioned, well, what if all these packets are out of order? Well, with TCP, and because the packets are numbered, that's how it can rearrange um, and reorder itself. And if you want to think about that from a hacking perspective, um, there are with that knowledge, right? Hackers can do a lot with TCP. Um, there's something called I'm not going to get into it. This is a deep because that's a deep dive, and I don't want to digress. But you can look it up yourself. It's called packet fragmentation. And that's how hackers can basically break up this malware or malicious packets, and that's how and they break it up and intentionally misorder them, right? So that way, when you send it through the internet and you try to send it to your target, maybe the firewall or the detection systems won't pick it up just because, because it's all out of order, intentionally out of order. Um, so, it can get really complex. And then obviously HTTP. Um, if, for the most part, most websites should be using HTTPS, S being the more secure version, the encrypted version, right? Nowadays, you can even set on your browser only to allow you to visit websites that have only HTTPS. I would highly encourage to turn that on. So yeah, we talked about the TCP/IP model, right? Uh, and so the TCP/IP model is known as a protocol model, and it's known as a protocol model because it describes the function that occurs at each layer of the protocols, right? So basically, it's just describing each layer, what's happening at each layer, right? So at the network layer, this is where your switches are at, the types of cables, right? The NICs, your network interface cards. The internet layer, this is IP addressing. Think of the internet with IP addresses. Um, transport layer, this is going to be TCP or UDP, right? We haven't talked about UDP, but we'll get into UDP later. Just understand that with transport, think of TCP, UDP, and also think of something called ports. And then last one is application. This is just the think of HTTP, right? This is basically like the how do I describe this? Um, it's pretty much everything like so all of these, right? Like you go to a website or you're trying to access your emails or you're going on a Nike.com or Google.com like that think of that like like the final product when you get there, that's the application, right? Um, so there's the TCP/IP model, and this is an older model. It was made in the early 70s. We still use it. Still good to know. You actually should know this. But nowadays, we've upgraded to the OSI model, the OSI reference model. And reference model, so a reference model is not intended to provide a sufficient level of detail to define precisely how each protocol should work at each layer. The purpose of the reference model is to aid in clear understanding of the functions and processes necessary for network communication. Okay, so physical layer, this is cables, right? Data link, think of your NICs and switches. Network, think of your routers and IP. Transport, that's going to be TCP or UDP. Um, don't for networking essentials, you don't really. I mean, it's good. Look, it's really good to know layer 5, layer 6, and layer 7, right? But for networking essentials, layer 5 and layer 6, um, really not relevant. Layer 7 is because we'll see when we compare those two models. You'll see that there are going to be things that actually are pretty much the same, right? But it's good to know presentation and session. Like at least know the OSI model. Like layer 6 is presentation, layer 5 is session. Like it's good to know that information, right? There's something called the upper and lower layers. So the upper layers are known 765. So like these are pretty much grouped and bunched up. And then you got the lower layers. Um, not too entirely important to know. I mean, it's just here's something. So like with upper layers, you just need to know like upper layers. Think of like again like the applications, right? The applications, the like think of your email files, your web browsers, your servers. Think of um, DNS, DHCP. Like this is where upper layer. Those are going to be in the upper layer, and then um, like I said, layer three, IP addressing and routing. Layer two is going to be our NICs, our switches, and then layer one. These are going to be the, the cables. Hubs and repeaters. I mean, dude, those are so like I don't think anyone use hubs and repeaters just because it's super outdated and they're really just not efficient. And we'll later on learn why we've moved away from hubs and repeaters, and now we're just using switches now for the most part. Um, but yeah, let's so here's the comparison, right? So as you can see with the OSI and TCP/IP model, um, there's in the TCP model, there's application, right? And then this is why I said 5 and 6. It's I mean it's good to know presentation and session. Um, I mean you should generally know like what is occurring at these layers, but again, like we bunched them up together, right? TCP model pretty much bunches these up, and they're all so again for networking essentials for this course, you it's good to know, but we're more focused on the application layer. Um, there's a transport layer, right? We're seeing pretty much same things, and then this is where we differ, right? Internet and network. I mean, if you think about it, it's pretty same, but this is where it gets a little different. The network layer. Think of the network access layer as data link and physical. So yeah, key similarities are in the transport and network layers. However, the two models differ in how they relate to the layers above and below each layer. So once we get past this transport and network, um, these the lower layer and the upper layers are a little bit different. Um, you can read this on your own if you want. It's not just know again. OSI 7 layers, TCP/IP model 4 layers. You should know that application are they're similar in application and transport, and they kind of differ between the network access and the physical data link. Let's check our understanding. Uh, which protocol is responsible for guaranteeing reliable delivery? If you remember in the video, it was TCP. Which protocol is used by routers to forward messages? Routers, when you think of routers, think of IPs. Which two layers of the OSI model maps directly as the single network access layer in the TCP/IP model? If you remember, that was the physical and data link, right? Network access, data link, physical. And then IP addressing occurs at what layer? Remember, guys, when you think of IP addressing, think of network, at least in the OSI model, right? In the TCP model, it'll be known as the internet, but you already knew that. So the rise of Ethernet. So, a long time ago, we didn't have Ethernet 802.3 because a long time ago, there were many companies like IBM. I've never heard of NCR, HP, Xerox. Like, so there were many, here's these five big players, right? And each of these companies had their own version of like the Ethernet cable. So if you had an IBM computer, you could only use IBM Ethernet. You could only use their version of the Ethernet cable. If you had a Xerox computer, you could only use their version of the Ethernet cable, and vice versa, like etc. Right? So each of these companies, for their specific computers, had a specific cable for them. And you probably can see the problem with that, right? Like like the proprietary technology, like it just, you can see, there was just so much, right? And with companies, like with big companies, that means you would have to only buy this. Like you can never mix and match, right? You can't have NCR computers mixing with IBM computers, right? Like if you're in a company with more than 200 employees, you can only have one certain um, one certain company's computer. Okay, I mean that's okay, right? I mean, I guess you can do that. You can go with it, but what happens if those companies end up failing? And then what? You have to go buy another 200 computers later on, like, you know? And so they started realizing that this is a problem. We all need to come together in agreement and decide, okay, well, we all need to like come to an agreement and decide which cable is going to rule them all. The one cable to rule them all, right? So all these companies came together, right? Like the Lord of the Rings, all the different races came together, and they had to decide, like, okay, guys, like which one is going to be the one. And obviously today we are at the 802.3, the Ethernet cable that you see today. Um, that is the winner, the breadwinner. And they all agree that this is, from now on, we're going to use this Ethernet cable, and all computers should be, from standard, just by default, all computers are going to be able to use 802.3 Ethernet cables. Um, and over time, obviously, so this is like a video of the timeline, not too entirely important, but obviously, as time went by, these cables got better and we're able to increase bandwidth. And nowadays, some Ethernet cables can deliver gigabits, really crazy amount of speed and bandwidth. And we talked about NICs, right? Network interface cards. Um, and we talked about MAC addresses, right? And I talked about how with each nick you have unique. So each nick is unique, right? You can never have two of the same nicks. Like my phone, like even though there are a million iPhones, each iPhone is unique. Each iPhone has its own ID. Um, so with each nick also comes uh, a unique physical address, right? The NIC is a physical network interface card, right? It's a physical thing. Within that NIC, there's something called a media access control address, MAC address. Um, so here they said every Ethernet network interface card has a physical address assigned to it. This is known as the MAC address. The MAC address identifies each source and destination host on the network. So again, just because there are a million iPhones out there does not mean that all million iPhones are the same. Sure, they have the same technology, they have the same screen, and they have everything's the same, but that nick, right? And that nick is what's going to differentiate it from everyone else. And that's how computers work too, right? Just because um, everyone has a MacBook, like let's say you have everyone in the network has a MacBook, that doesn't mean everyone has the same ID, right? Again, each MacBook has its own NIC. My laptop has a NIC. Your laptop has a NIC. My computer has a NIC. Everybody's devices have these NICs, and with each NIC is going to come with its own MAC address, and that's how computers know and identify each other on a network is through the MAC address. So let's watch this video. And so this is at layer 2, right? Again, we talked about OSI model, layer 2, OSI model, TCPI model, MAC address, NICs. That's going to be at the physical layer, right? The That's going to be at the it's going to be at the so with the OSI with the TCP/IP model, that's going to be at the network access, the physical layer. Um, with the OSI model, that's going to be at the data link layer 2. So these MAC addresses occur at the data link layer 2, and this is obviously an example, right? And your MAC address is not going to look like CCC. It's going to be a combination of different characters. But this is how computers communicate, right? So um, I need to send. So this H1 is like I need to send this packet to H3, and so later on we'll figure out. Okay, well, hold up, Moses. You're probably asking, right? Like, okay, hold up, Moses. What if all these computers are just connected to the network? Well, then how do they know where to send packets? Because they don't know the destination. How else are they gonna know? That's a great question, and we will get into that next chapter, I believe. Yeah, we'll get into that in the next chapter, I believe, and that's going to be something called ARPing and the MAC address table. So yeah, we will talk about that actually in the next chapter, and that's a great question you to think, right? It's like, well, if these computers are all in the network, but they're all new to the network, how are they going to know how to send the packet when they doesn't even know that the other computer exists? And that's a great question. Hold on to that question. I'll give you, and like I said, I gave you the hint. It's called ARPing, Address Resolution Protocol. If you want to go ahead and look that up and be ahead of the game, do so. Um, but yeah, that's how they're gonna do it, and we'll talk about that next chapter. Um, for this example, we're just showing, right? The computers have MAC addresses, and that's how they're able to communicate each other in the local network. Keyword is local. MAC addresses are important in the local network, right? Once it gets outside of the local network, aka when it leaves the network and then you have to use a router, um, I'm not saying MAC addresses aren't important. You still need the MAC address, but it's gonna be you need more than just the MAC address. When you're in the local area network, uh, MAC address, and that's gonna conclude this chapter. And we learned that what are rules, and we talked about protocols, and we talked about the three elements required, and that's source, sender, destination, receiver, and the medium. How does the how does the data travel? We talked about communication standards and how we've reached to this point. Um, like how we understand that there are organizations out there that govern and have made standard and rules for all devices using the internet. We talked about requests for comments, um, and then we talked about the most important out of this chapter, the most important thing to remember and learn by heart is the TCP and the OSI model. And then we also learned about Ethernet. Next chapter, we will talk about, we're going to talk about, yeah, uh, encapsulation, right? That word that I said that you really need to learn. And yeah, here, yeah. So when I said earlier that frames So yeah, I was right. It can go up to 1518 bytes, and then the lowest is 64 bytes. So yeah, I think I was right about that. But we're gonna learn. We're gonna learn all of this stuff, guys. And let's see. We're gonna talk about ARPing in this chapter. I just want to make sure that this chapter is talking about ARPing. Yes, yes. We're gonna learn broadcasting, and that's how. Yep, yep. ARPing. Yeah. So this chapter we'll learn how. Okay, Moses. How do computers know if that computer is even in the network? We'll learn about that in chapter 6. I don't think I'm gonna stream tomorrow or Sunday. Usually weekends I'm very, very busy. Um, Monday, most likely Monday. We'll pick it back up on Monday. But thank you guys for stopping by. I hope you had a good time, and I hope that I'm teaching this. Hope I'm teaching um, these things well, and I hope that I'm not confusing people, and I hope I'm explaining things better than just reading the textbook. Um, if not, let me know. I'm always open to suggestions and comments. But thanks again. Till next time, take care and love y'all. Peace.